In the previous video, we looked at two different ways of comparing shapes, congruent and similar. Congruent means it's exactly the same. Similar means it's not exactly the same, but it has the same proportions. An example, determine angle 1. Now, first of all, what I'm going to see is I'm going to compare triangle GHF and triangle HMP. To do that, I take FH divided by HP, and that's 15/6, which comes out to 5/2, which is 2.5, right? Yeah. Then let me take GF over MP, 7.5/3, which is also 2.5. And lastly, GH over HM is 13/5.2, which also comes out to 2.5. What this tells me is that we have that the triangle GHF is similar to the triangle MHP. Why? Because the ratios of the sides are proportional, which means, what does that mean? That means angle GHF equals angle MHP corresponding. But this is 30 degrees and this is 1. So angle 1 is 30 degrees. So what's the result? The conclusion we can draw from this is if the corresponding sides of two triangles are proportional, the triangles are similar. So when you have these problems and the problem does not tell you that triangles are similar, you may be expected to find out that the triangles are similar. So one of those ways in which triangles can be similar is when their sides are in the same proportion. The second way is if two sides of triangles are proportional to two sides of another triangle, and if the angle included between those sides are equal, then the triangles are similar. So here, let's compare triangle ABE and triangle CDE. What I have is AE divided by DE is 90/30, which is 3, and I have BE divided by CE is 75/25, which is 3. Now, unlike the previous scenario, I do not know AB and I know CD. But what I have here, two sides have the same proportion. And then it says the angles included between sides. The angle included between AE and EB is this angle. Let's say I call it angle 1. And the angle between CE and DE is this angle 2. And I can say angle 1 equals angle 2 because they are opposite angles, which you can recall from the first video. Which means that what this tells us is if two sides are in proportion and the opposite angles are equal, then the triangle ABE is similar to the triangle CDE, which also means additionally that the ratio of AB over CD must be the same, which is 3, or AB over 42 equals 3. You cross multiply, you get AB is 42 times 3, which is 126 feet. So again, that's another way in which two triangles can be similar. Now, within a triangle, if a line is parallel to one side and it intersects to other two sides, the triangle formed and the given triangle are similar. So in this case, we say that this smaller triangle BED is similar to the larger triangle ABC. You can sort of imagine why this is true, because if you stretch the smaller triangle, it overlaps with the larger triangle. Example of this: say a design change is made in a building. A roof span, which was originally 36 feet, now has to be changed to 30 feet. Assume that this change is in such a way that it's parallel to the original rafter, which had a length of 18 feet. And the overhang is everything else remains the same. And this overhang is 1 feet. So GD, so wanting to know GD, which is the new overhang, is still 1 feet. But we know from our result just now that the triangle BED is similar to the triangle BC. I haven't used A, so maybe let's call this A. BCA. This means that if I take the ratio of AB to DB, it should equal the ratio of AC to DE, corresponding sides again. Now what is AB? That's the original span. That was 36 feet. DB is the new span, which is 30. AC is the original rafter length, which is 18. And DE is what we are trying to find. So cross multiply, and what you get is 36 times DE is 30 times 18. So you get DE is 30 times 18 over 36. Canceling out gives you 15 feet. But remember, you're trying to find the total length GE, which is DE plus the overhang, which is fixed at 1 feet. So it's actually 15 feet plus 1 feet, which is 16 feet or 16 feet. Again, box your final result. And the last thing is this last one. Yeah, so the last case in which you can have similar triangles is if you start with a right angle triangle and then you draw an altitude, then you get these two triangles. And in fact, what you have is the triangle MST is similar to the triangle PST, which is similar to the triangle PMS. So not only do you have, when you drop the altitude, you have two triangles that are similar, but it's also similar to the bigger triangle. In this problem, let's say you're given MP is 254, PS is 150, MS is 180. You have to find MT and PT. First of all, let's look at the two smaller triangles. In this two smaller triangle, I have MS over PS equals MT over PT. But I know what MS is, that's 180, and I know what PS is, that's 150, is MT over PT. Now I can simplify this a little bit. This is 6 over 5, and then I can cross multiply. Cross multiply, I get 6 PT equals 5 MT. Oh, what else do I have? I also know that MT plus PT is actually 234, right? Because I know the total length. Now from here, I get that PT is 5/6 of empty. So I can plug this in here as empty plus 5/6 of empty is 234. Taking the fraction common, I get 11/6 empty is 234, or again cross multiplying. So cross multiply, empty is 6 times 234 over 11. That's, oh, that doesn't divide, never mind. You can plug this into the calculator to get the value for empty. Again, try and finish this problem on your own. That's the end of this video.